So we talked about prisms. Something that often goes hand in hand with prisms are cylinders. A cylinder is a three-dimensional figure with two circular bases connected by a direct surface. I'm sorry, two congruent circular bases. It's very important. If they're not congruent, they would be a frustum. So a cylinder. I hope you guys have encountered cylinders before, whether it's just a cup or a bucket or a can, but a cylinder. If the height is perpendicular to the radii, if this side is perpendicular to the radius, it is a right cylinder. All right. Another way to say that is if the segment connecting the centers of the bases is perpendicular, it is a right cylinder. We have our two bases. They are the two circles. But there are no base edges this time. Because there are no edges, there are no polygons intercepting each other. So we've got two circles and then this smooth surface in between them. That smooth surface in between is called the lateral surface. It is a lateral surface because it is not a lateral face. A face is a polygon. A face of a three-dimensional figure is a polygon. So technically, these bases aren't faces, but a lot of times people in the math fields do refer to the circular bases as faces because they do belong in a plane. So if you refer to the circles as faces, that's fine, but this curved surface between the two circles is not a face. All right? So we've got the two bases and a lateral surface. So unlike the prisms, where you had two bases and then at least three lateral surfaces, there is always just one lateral surface for a cylinder. Now it's also trickier for the net of a cylinder than a prism. But the easiest way to show it is just with a piece of paper. If I took this paper and I rolled it up, I've just turned it into a cylinder. Imagine that's rolled up nicely. I've just turned it into a cylinder. We've got the open circle on top, open circle on the bottom, but if I close those, it will be a full cylinder. So this rectangle that was our piece of paper is what yields that lateral surface. So this is our lateral area. The lateral area this time is a rectangle, and we've got the two circular bases on either side of it. The lateral area has the same height as the cylinder did. And this distance, if we reconstructed our cylinder from this net, this would wrap around to here, that would wrap around, and these two edges would meet somewhere about there, if this was more to scale. So this is the distance around the circle. It's the circumference of the base, 2 pi r. And this is pi r squared. This is pi r squared. So, for a cylinder, in essence, its lateral area and surface area are the same as they were for a prism. It's still the perimeter of the base times the height, but perimeter in a circle is circumference. So it's 2 pi rh. And the surface area, it's still the lateral area plus 2 times the base area, but the lateral area, it's 2 pi rh. And the base area is pi r squared. There's not going to be a different type of shape for the base. It's always going to be a circle. So these are our formulas for the lateral area and surface area of a cylinder. Lastly, with the cylinder is the volume. So if we want the volume, it's still in that same family of the prism, where it's the area of the base times the height. Except this time there's only one formula for the area of the base. It's pi r squared times the height. All right, so that's surface area volume of cylinders. Tune in next week. We'll talk about pyramids and cones. And then shortly after that, spheres and composite figures. But that's it for this week. Have fun.